Hello everyone, welcome back to Chat with Kaushik. In this video, we'll be going to discuss about threading, and threading is a very important topic. If your projects or job description has the threading keyword, so and also you are expected to code in interview some basic threads, and you'll get the follow-up questions like what is a join of mean, how do you what is a runnable, what is a callable, what is synchronized keyword mean, and how do you use that? What is inter-thread communication and all? So these type of questions can be answered if you know some trading basics. And I'll keep this video short. I'll give first half in Java and second half in Python. You can skip accordingly. So let's just start. What are the different tradings we have? Ways you can do trading. Like I have created a class trading basics, and I wrote a static void main function. And let's just start. There is a inbuilt thread class through which we make threads. Like for suppose I create a thread Q1 new thread of, and I can give a target method. It can be of a lambda method for now. I'll keep it so simple. Like I'll write one one and okay, I'll start this thread. I will you can join this. I'll tell you what's joining. Mhm. And, yeah. Basically, the join mean like until this thread completes the main thread. Wait. Let's see what's the main thread is. For suppose I want to know what's the current thread running. So we had inbuilt methods like for example thread.current thread dot get name of. So there is no thread, right? When I run this one, what happens is we'll have a main thread. Whenever the JVM starts a program, we'll have a main thread. If you can see the output is name. The name of the thread is name. The first thread that runs is a main thread. And the rest of the threads that it creates will be run. So what does join mean is until these thread T1 completes, the main thread should not terminate or release the resources. There is a problem here. Sometimes this T1 thread can raise an exception, interrupt exception. So we have to either use try catch and handle it, or you can throw that to JVM itself. So it's a exception that can be handled by JVM too. So I just throw it to JVM. Let's see what happens. Yeah. So you can see, we got the output like I'm running. So what happens here is when T1.start is run, like the target method runs. Okay, this is the one basic way to create a thread, but we generally do not use this. We will use the custom threads in the projects or everywhere, right? So how do we create a custom thread? Let's discuss that. So let me just write a custom thread. For that, I'll import from java.tutorial concurrent. I'll import all like so that I don't have to import multiple threads. We will get all the runable callables and all the interfaces we require. So for for now, I'll consider this as a type one. Type one is basic threading. That's like how we do in our projects. Like for suppose I had a class called my thread. I'll extend that with thread class. So what happens? I'll get all the thread class properties here, and I can override the run method here present here, and I can execute my custom logic. And this my thread object will behave as threads now. This is how we create a custom thread. So I'll use I'll write a basic run method. So, running. And anyhow, the JVM keeps the default constructor. So for this, I don't have to write any constructor too. Yeah. So let me just quickly create a class, an object for that, and we'll discuss. it. So for my thread, I'll create a thread called my thread, and I'll call g1.starter. And let me see, I'll join this. Make the main thread wait until my T1 completes, and let's see. Type 1 is running. So this is one of the way, like you create your own threads, like you had your own object, right? So you can write multiple methods inside this. So this is like basic, but how we use that in real time is in my IoT project for every sensor, I created a custom thread. Like for suppose I had ultrasonic sensor, I had a class ultrasonic sensor extended, and then I wrote all the custom logic that like I require for that in the methods, and the run method will be the main one that runs when I start the thread. That's how we will create IoT projects, or you can write your testing logics here. So custom thread. This is one of the way. Then there are other ways too. Let's discuss some other types like type two. In type two, we'll discuss about the runnable. Let's consider like my class runnable implements. the interface runnable, and let me just create a quick run method. I wrote the override annotation because it will tell in compile time itself like I'm overriding that run method. Okay, I'll create a base run method and then write some title run. And for that sake, to run this, basically you cannot run me directly, like you can't create an object and write start off. Like for suppose my runnable class type R1 is equal to new my runnable of. I created an object for that. Now I can't write R1 dot start off because it's not a thread. It's actually a runnable object. So what I have to do is I have to create a thread object, and in that thread object, I can assign this runnable to that as a target, so that it can run. So I have created the thread with the T1 name, so I have to start with the T1, not R1, okay? And I'll wait to make the main method wait until it completes. Let's see happening. Yeah, you can see that I2 is running. Uh, that's one way to create runnable interface, and you can write your own custom logics inside that. And there is another way you can create that is called the callable. Let's see the type name. Yeah, callable implements callable. Let's consider like you have to mention the return type. Like why? Because callable is like you imagine it's a function call, like will return something. So you have to mention that as integer or something, or you can keep it as generics too. If you know generics or wildcards and all, you can use them here. Okay, to keep this simple, I'll write some basic call method now. Okay, public the return type is integer. I told you public call methods, and let me print like and type 3. Yeah, I told you how to return something, right? I will return some integer one. Like whenever we call that, it will return. So we made our object as a callable object. You will get to know. Okay, but there is one thing. To execute it and show, or in real time, how we use that is there is a different use case. We will not use it directly. We generally create a executor service. We call it as a executor service because even in Python or any other language, uh, executor services are actually an inbuilt classes where they are written cleanly to start and then to run the threads. So suppose there are single thread executors, there are pool of thread, fixed pool thread. There are different types of subclasses, I mean classes that implements this executor service. So executor service is actually a kind of you can tell interface. Uh, you can see what is an executor service, right? It's a public interface. And okay, I'll create a pool. Pool is nothing but where there will be several s- what we call several threads running together and they are handled together. Okay, let me create a basic one. Like I'll create executors dot. There are several pools you can see here, right? I'll create a very basic one that is a new single thread executor. Okay, and you should know another concept called future of. Future, what is future? Future is actually, again, it's a class. You have to type, I mentioned the type. What is it? Is a promise kind of thing. So whatever the thing that will be written, obviously the callable ones will return this, what we call the integer, right? So when you submit the job to the executed code, you had a promise like the pool promised you it will return some integer to you. So you can use the concept of future to hold that. So let's take future of integer and I'll submit my uh, callable object. So I can create a callable, I'll create an anonymous object. Anonymous object is like I can create my here itself without any variables. Like I'll create new my callable off, and that's how. Now we can get the value. Like what is the so what are the advantage of feature is you had some functions in that like is done f dot is done. You had like it returns boolean like whether the whole the promise is done or not. You get you had a get method like it will tell it will return whatever the callable return. So let's see that one. Okay. Uh, let's see. We had another execution exception that is added here, like it with Java. Uh, we have thrown that to JVM itself to handle it because it's an executor service internally, like just like interrupt exception, it will raise these what do you call it? The execute exception. So that's why we wrote execute exception here. And yeah, new single thread executor. And we had a feature because we had a promise like who will return an integer. And now we got that and we are trying to print this. Okay. Before that, one thing is we have to shut down the pool so that it will cleanly close everything. Or else we will be facing problem like the pool will be running the thread continuously in the background. So this is how we write the callable method. Callable object we'll create and we'll give it to some pool or execute a service object, and we will take that promise to a future uh, object like f, and then we'll use that methods like get is done and to understand what's happening with that callable object. Okay, if you just run this first. Yeah, I'm type 3 running and I have printed what are the return value 1. So that's why it got print f.get, and I shut down the pool. This way we use the callable one, and this is how we had different three types of ways to create a custom method. And the interview questions would be like, what is the difference between a runnable and like a callable? Like you can tell you had a return type here, and also the exception propagates, so you can handle in run method if there is an internal exception occur, it cannot be you have to handle there only. It cannot propagate down because you are not calling it right. Generally, in Java exception handling, we had two keywords, throws and throw. Throw is actually it will raise the exception. Throws is like will throw that to the call. So since main method is called by JVM, we have thrown the exceptions that rise here to JVM. JVM handles that. For suppose if but in the advantage is the callable. Since it's a callable, you had like the return thing, so you can even make the exception propagate to the call position, just like the call is with JVM, so we have propagated the exception right here to JVM. Like if there is a call of the my callable here in the main method, like if any exception occur here, it will be you can write here throws and then uh, propagate it down to the call till where the call is there. But you cannot do that in runnable since it's not a call, it's something that cannot be called. You cannot propagate the exception, so you have to handle that in the run method itself. That's the major difference. So what is the difference between a run method and a callable, runnable and a callable? Runnable will not have a return type and it cannot propagate the exceptions to down the call. Like, but callable can do those both. That's a major difference. And that's an interview question too. Okay, now let's just quickly see some more basic. Like you know what is join off, right? And there is another thing called sleep, red dot sleep. Uh, I'll I'll quickly comment this one. Yeah. Right. Um, Let me uncomment the thread one and my thread two. I'll write it at T2. Yeah. Now I have two threads, right? Now I'll create some sleep here. We had a thread dot sleep off where you can view the range in long milliseconds that you can tell. So for suppose I write 100 milliseconds, then it will wait. So what happens is the thread sleeps for 100 milliseconds and wait and then create the new object and then run this. So which thread is sleeping? Not the T1 thread, the main thread. The main thread when it's running, it will start the thread and after that it will read this one and then sleep for 10 milliseconds and then it will create new object for T2 and then run this. So let's just see. You can see there is a small delay in between them, or I'll increase the time to know the difference. If you can see after my run, I'm running, there is a little gap between the type 1 running. That is around 800 milliseconds. Okay, let's now quickly jump into synchronization. Synchronization is another interesting concept that is asked, and I'll make a separate video on synchronization because it's very important. You had a classic problems on synchronization. the timing philosopher, reader, writer, and producer, consumer. Producer, consumer, even in internship offers for the juniors too, they'll ask because that's the expected question in a in a OS. Like they'll either ask you pseudocode orally or they'll ask you to code entirely the producer, consumer. Even my friend who gave an interview for Visa and my friend who gave recently for the full-time offer for IDFC, they asked to code the producer, consumer entirely. So you should opt any language, either a Python or Java, and then code that. So that's why I'll create a separate video for that. For now, we will discuss what is the basic synchronization, synchronize the keywords. We call it as intrinsic locks. Let's see that. I'll just erase this. I'll upload a clear notes for this in the description. You can check it there. Okay. Let's come back to our synchronization. Okay. What is an intrinsic lock? Actually, is like we had a keyword in Java called synchronize. It can be used in two ways, like at method level. Like you can write a methods like suppose I'll create a method called something. First, I'll create a private. Uh, Let me create a private variable val equal to 0. Okay. I created an integer val. Now let me create some synchronized thing. Like I'll create a public method, public synchronize. Remember, the synchronize should be immediately after public, or else you'll get an error. Public synchronize. What shall we call? Uh, shall we call it as incrementer or something like tell like it is increasing, right? So it will not return anything. So public synchronize void increase of. Okay. Then what we'll do is we will increment the value inside it. Yeah. So what happens here is this method is now synchronized method. Okay. Because this keyword ensures that if multiple threads are accessing value in increase method, not value, we did not keep lock for this. We kept only for the increase method. When multiple threads are accessing, thread objects are accessing this increase method, only one thread will access at one time. It's like a critical section for them. Okay, to increase this. This way we can use, or we had another way. Like for suppose I'll create another method. You can see that is block level synchronization. Because let's say public void increase increase type 2. So in this, what happens? I'll have a val plus plus, right? So to make it synchronize, I don't have to make the entire method synchronize. I can make only this region where I'm using the common resources synchronize. So I use synchronize of this, and then I will keep the lock. So what happens is this region, whatever is there, is called synchronized block, and the block level synchronization we call. So this will allow us this is nothing but the runtime object, right? So the runtime object will have the synchronization based on that. So this is just the name of the lock. You can keep anything. You can create your own like a lock, something like some random name, and over that you can create too, so that you can maintain several locks. Like for suppose private. You can create some object class like lock one, something like object of, and over lock one you can create the synchronization group. So what happens is you will have more control over locks, so you can get multiple locks and you can do this is also allowed this way, or anything is fine. So what is this? This is at instance level. Instance level in the sense you had an instance variable and you have used a synchronized keyword for instance method and block level synchronization inside an instance method. Right? What is an instance method? Because that for every object I create for the threading basics, these methods are unique. Like the value is unique and these methods run uniquely, right? So instance is related to object. Then what about the static methods? So the synchronization can be done at class level. It's class level also. Let's see some example. Like suppose the same. I'll write something like logging or something like that. Like public. Alright, static is the keyword that tells that this method is related to class level, right? Public static synchronized void. I'll tell some log static. Okay, log static or something like that. So because I'm doing log using the static method, I just named it as log static. Okay, and we can write something like I'm logging log static in the sense we can tell I have updated the log or something like that. Okay, everything is fine. So here this log static is a static method that is synchronized. It's the same way. It's a keyword is added. Uh, But at block level, if you want to do this one at the block level, then you have to use a different way. Like instead of an instance object here, what you do is you get synchronize and you write you write your class name dot class. Like for suppose mine is threading basics dot class. This like this you write. So what happens is over the class, this block is this intrinsic block is created. Okay, that's how you will write for the static one. And this is how we do Java's threading. I told you the synchronization and some threading basics, right? Now let's quickly discuss some small basic inter-thread communication. So there will be no much difficulty in inter-thread communication. Inter-thread communication because the threads are something that runs in the same memory, so you don't have to make such special things for communicating. Even a variable is enough to communicate. Like for suppose the value is there, where the val is communicating between multiple threads, right? Just synchronized variables or synchronized methods can run, or you can create the priority queues because queues are something they are very thread safe. What is a it's a basic question, which is the most efficient thread data structure? The queues actually. And in Java, we have an interface called blocking queue. Like I'll show you. We had an interface like blocking queue. This is the interface, and in that interface is being implemented by two different classes. They are array blocking queue and linked list blocking queue, linked blocking queue. So where internally array and linked list are used. So that is queue only, but they are specifically designed for thread safety. That's how we use inter-thread communication. If your project has specific inter-thread communication, please focus on that one. Okay, let's now proceed with Python multithreading. In Python, generally multithreading is not that preferable because there is a global interpreter lock, we call it as GIL, which enables Python only to run a bytecode, a single thread bytecode. So there is no true parallelism in multi-threading. So you can't run multiple tasks simultaneously just like in other languages because there's a lock over the interpreter because interpreter here is a common resource for multiple threads. So just like you think it is synchronized to use the interpreter, and that's how. But the recent updates, like around from the 3.13, the latest update, they have given an option to disable the GIL and using GIL disable flag like in C Python. So it's the latest upgrades that they're bringing. But still, multi-threading in Python is useful. Like you can use it for multiple request handlings and IO devices, inputs and outputs one, like file downloading, uploading, and all. So let's see the Python multi-threading quickly. Okay, for the sake, you have to generally import the threading and library here. Let's consider a function. Let's consider a function like for suppose I had a worker method. Like I'll write working or something like that. Now, if you want to create a thread, the same like in Java or any other language, you can create a threading.thread or class object, and for that it will give you target as a worker method, and you will give a name like you can give a name even in Java too, like you give you a name like some worker w1 or something, and you can start this dot start method. If you join has the same meaning. Here too the main method is there, but not visible. It's like the file that is being run. So before that file running, uh, like I will wait for this thread. Join in the sense the main thread will wait for the completion of the thread T1. Okay, and you can see I'm running, I'm working and done. Yeah. And then we have a custom threads in Python. It's simple. You don't have multiple things like callable, runnable, and all. You have them, but generally we use multi-threading in Python using these extends way. Like you will inherit. Like for suppose there's a class my thread. So I want to extend this, so I'll extend threading.thread class, and let me override the run method. I'll print and custom thread running, and you can create an object since it's a custom thread. You can create and you start, you don't join, then that you're done. If you see, this is how we write custom threads. What the use of custom thread is like this class, you can write your instance methods, you can write your own things. Just like I mentioned, right? In my OT projects, I write a class for every sensor so that I can, if there are multiple same sensors in the project, I'll create objects for them, and all the behavior of each sensor is written here along with the run method. So I can run them in thread. The main logic will be in the run method, and the helper functions will be there in the class. That's how you can isolate your code and use the multi-threading. And if you come regarding the runnable. runnable, it is actually the same as like the target one, because even in Java or any other language too, we create a threading object and give it as a target. So here, instead of creating a class, the same way we'll create a method and we'll print this the same as it is like how we did with the first example. I'll create a threading object and I'll give it a target of an enable. See, I should not call this. This is just a method name we are giving, so I'll not call that. Name of the method is enough. Like name equal to enable. And if I start this, the same. Like this is how we implement. If you had any runnable, you will just make it a target for that threading object. And for suppose you have callable, something which is need to be called, then it's the case is different. Then you have to write. For suppose there's a method my callable, something like that, and you're telling printing that okay, I'm callable, I'm running like this. Now you have to execute it with some executor without that you can't. So I'll use with is actually a context manager. Like you don't have to shut down or you don't have to do the closing activities. With will internally handle it because the class that I am going to use now I internally had the context manager methods that will run immediately after completion of the with block. So they will close the required things. So now I'll write a thread pool executor. Okay. For that, I have to import Redpool executor. I have to import. So from concurrent dot futures import Redpool executor. So with the Redpool executor, like you can tell how many workers you can have like maximum workers. Like that's telling you're telling how many threads are required for completing the task. If you give more number of workers, the task will complete faster. If it has a multiple subtasks, it will complete faster if you give more workers. Okay, now for suppose I'll give max worker as one and as pool. Let's consider this as a pool. As is aliasing. Okay, now let's consider future just like we discussed, like future is in Java coding, we discussed like future is interface there. Just like we will consider here too. Like we don't have type mentioning and all. This it's a variable for now. Future is like what we are doing is we're submitting our callable like to the pool, and it promises the return time. So I didn't return anything in the callable, right? Let's return some value like return one. Yeah. So that one which is promised, it will get returned to future variable, and now we will print the future dot result of just like f dot get in the Java, we had a result of like this is how we'll run them. And let's see what's happening. Yeah, I'm callable running and it returned it the one value. So we require the same as executor service. We had thread pool executors here with the maximum workers we require. We can keep that. And this is how we'll do this custom threading. Then what else we had? We had, the join method the same way, and we discussed sleep there, right? Threading the same way. Here we had a thread dot sleep. So suppose that is equal to uh, threading dot thread of some target equal to I'll write a lambda function lambda x equal to mm, or else we can give a target as some runnable itself already existing, right? Runnable. Then what else we had? We'll write I just want to show you the sleep option that we had in the uh, here. Generally, Python uses a separate package for that. That's a library we call. It is time module. Time.sleep, which is a famous one you see in the Python projects, right? Time.sleep generally stops the execution of the interpreter for a while. That's how we'll achieve the sleep in the threads too. Time.sleep, you'll use some milliseconds of around 800 like that. And I'll create, we'll start this one. Then I'll create another one. Like T1 is equal to threading dot thread of. So target equal to the same runnable. T1 dot start. Oh, like you can sense the delay when I run this. Okay. If you can see, it's telling I am callable running and all. Okay, I'm running, and you got 800. milliseconds. Generally, here we have in seconds, so I guess I have to decrease the time. Let's take it to some 3 seconds. Yeah, I'll rerun this. I'm running, and after 3 seconds, you'll get I'm running and done. Since it's their threads, they may close simultaneously. Since done, if you can see, you can observe what is the use of join. Let's see here. The both of them has the main thread has printed done, and also the subthread T1 also printed I am running. So I got mixed. But suppose if I write the T1 dot join and also uh, the T dot join, uh, sorry, T1 dot start and T dot join, then you can observe there will be a clear output for that. I'm running, and after 3 seconds, it will there. And after the thread gets completed, since you use join, thread is completed, then it will print. So before earlier when we didn't write join, what happened is they thought of completing simultaneously because main thread execution completed, so it printed done, and also simultaneously I'm running got also printed by the thread, so we got a overlapping line. But since it waited until they complete, you got a clean output, right? So join is used for that purposes. Like when you wait, you will get a cleaner results, step by step results. And the sleep, you have seen the 3 seconds delay between I am running, right? Sleep time dot sleep is the way we use in Python. And regarding callable, there is another thing like in Python. I'll explain that. Let me just first erase this. Yeah. So suppose you had any class, you can make its object as a callable one. That is out of this what we call this threading concept. Generally, we had some special methods. We call them when there is a double underscore on either side. We call them as special methods, right? They define the behavior of an object. Like this is an initializer, just like constructor in Java. Um, Let me tell I'm incrementing. So let's take self dot increment equal to increment, and let's see. Now I'll call this double underscore call double underscore of self. So what happens here is this makes this adder objects as a callable one. Like whatever I return, the object whenever we call the object, it will return it. Like I will show you. So suppose whatever the callable method we had, say like for suppose I send a value, so value plus we will write like whatever the incrementer we initialize, we will add that increment. So suppose I created an object of adder of two. Adder of two, whenever I call, it will add two because the increment value is two there, right? So yeah. Hmm. Then that's all. Like we made this, right? Now we will create an object. Let's say a is equal to some adder object. Like consider we will add two for always. So we create an adder object, right? So suppose you want to add like 10, then you'll create adder of 10. That's common. Okay. Now let's see how we'll use this. You can call this. Now a and a1 are what? They are actually objects, but the objects now are able to be called. Like for suppose a of, you can tell a of, and you'll give value to. And what happens? You give value to this will internally call this call method, and it will return whatever the object is. Like it will increment the two and then give it. So what we get 2 plus 2 4 we will get. I see you got 4. So suppose if I call a1 of 2, actually it's an adder of 10. Call method will add 10 value, so we will get 10 plus 2 12. Here is 12. So object reference are becoming like a methods. Like did you see? We are able to call this. That's due to callable thing. That is also an interview question that the people may ask regarding the special method double underscore call double underscore. Okay, this is different from the callable of what we are talking in context of the threading, but they're similar. They have written type, and we have to handle them. We handle here using thread pool executor in the threads. Okay, now we'll quickly discuss the synchronized keyword and wrap up this with interthread communication in Python. Okay, what is there is a built-in lock here, like threading.lock we call. Yeah. So threading.lock is a built-in one which we will use for locking things, and we will use this for making that synchronization for the blocks or synchronization for any method or else. So in this threading.lock as a context manager, so you can use this with keyword. Um, like for suppose, let me take the previous example itself. Like in that adder, so suppose there is a method like increment, right? So if I create a lock here, like for suppose self.log is equal to reading.log of, then this can be used with context like with log with the self dot now because it's internal one we should call this self dot log. If you return this, so this become a synchronized block now. with the log, if multiple threads are being called over call, if multiple threads are calling this call method, like then this will be handled using synchronously. So just a simple conflict manager will handle. It will handle the internal shutdowns and everything, the log removing and all. So once the log completes, that's the advantage of it. Okay, that's how we'll use this synchronization part, and I'll make a special video on synchronization. Okay. Now let's discuss about the inter-process communication, like inter-thread communication. In that, in Python, we don't have much inter-thread communication, like because it's all running on the same space. You will use synchronized blocks. If at all it's a process, you'll have multiple things to discuss, but it's inter-thread, so you will use the synchronized ones. You will use message queues or queues. Generally, the queue dot queue, like the class import from queue, you will have queue dot queue. Like you'll have a queue method like data structure. It is just like the queue which we use in the essay, that is like the first in will get first out, that is thread safe itself internally, so you can use that queue and then work on that. Okay, that's how. Thank you.